So clearly this one is all about Pacman, and thanks to Brilliant for sponsoring this video. I've wanted to add a neural network to Pacman for quite a while to see if he could figure out the first level maze. Coding it up wasn't too difficult, but I wanted to see it from the Pacman perspective. So this meant displaying it in 3D so I could wander about the maze myself. To do this I used Blender. Now 6 weeks ago I'd never heard of Blender, but because I wanted to make this shot for my last video, I downloaded it and gave it a go. So many tutorials later, largely involving bouncy squishy balls and cloth simulations, I was ready to start building out the maze. This meant grabbing a screenshot of the layout, importing it and adding detail. I spent quite a while playing around with textures and eventually settled on this setup. The portal is just another texture which has its position tied to the keyframe value. This is what makes it move as the animation progresses. I also experimented with the ghosts just to see what they would look like. But eventually went old school with it and stuck to the original for Pinky, Blinky, Inky and Clyde. They all have their own unique movement patterns which combined to trap Pacman. These are well documented and my own ghost AI attempted to replicate it. Not sure if I got it 100% correct, but it's good enough to chase him down. The idea behind this was quite straightforward. Code it up in such a way that I could have a lot of these games all running in parallel. So separate instances of Pacman being chased by ghosts, all in their own maze. Pacman of course is going to need a brain, something which will allow him to make decisions based on the game state and the positions of the ghosts. This information will be used to steer his next step in the game. So I plugged a neural network into each Pacman. In the first generation, each of these has random connections and hidden nodes to start with, but all of the same input and output layer structure. The inputs are simply the X and Y coordinates of the ghosts, the same for Pacman, and also the location of the nearest pellet. Every time the game tells Pacman to make a move, this information cascades through the network. The product of the connection weights and the input values then arrive at the input nodes of the next layer, where they are combined and applied to the activation function. From there they flow to the next layer, and so on until they reach the output nodes. I've gone with just a simple output setup. Depending on which of the outputs has the highest value, Pacman will make his move, either north, south, east or west. And this just repeats until everyone from that generation has died. Then those which have done best will have a greater chance of passing on their genes to the next generation. This is done via the crossover process, and the new networks are then mutated slightly to introduce some genetic variations. This mutation step includes the ability to randomly insert new nodes and connections into a network. I also have speciation enabled, which gives these mutations a chance to embed themselves and stretch their legs to see if they add any value. Any species which doesn't improve within 20 generations has the number of offspring they're allowed to have reduced by 50% in the next generation. And then it's on to the next generation, and this process repeats. And as the generations pass, the population gets better and better at surviving and scoring points in the Pacman maze. Or at least that's the theory. It really did struggle, and I spent a while trying out different fitness functions, population sizing, and initial connection weight parameters. The issue turned out to be the top-down nature of the direction output from the neural network. It seemed to have an issue with the lack of reference to its own heading, so I made a change to allow it to simply define its next step as forward, backward, or left-right. This had a big impact, and as the generations passed, it evolved the ability to navigate the maze, collect pellets, and avoid the ghosts. The better performers seemed to really like the portal and gave it some extra attention. But as I was doing this outside of Blender, how did I get the game info into the 3D environment I'd created for it? All I did was create a function which would store the movement of all creatures and the game state. So for any game from any generation, I could grab its data and represent it in Blender. Blender comes with Python out of the box. Most Blender videos don't focus on it, but it's incredibly powerful and exposes the entire object model. With just a few lines of code, you can create very complex organic shapes, as well as keyframing the movement of objects and materials. Here I've used it to create some dancing cubes. It was only 8 lines of code. I used Python to import the games into Blender so I could display them. I started learning Python last year. It seemed to make sense as it's the most popular language out there. I started with free online tutorials, and the free tutorials over at Brilliant are excellent. Brilliant is a website and app that teaches you all kinds of STEM concepts, from computer science through to astrophysics. Most of my coding these days is done in Python. It's an excellent and very relevant first language for new programmers. The interactive course on Brilliant covers all the basics you'll need to know to get started. Loops, functions, variables, and data visualization topics are all covered in great detail. There is a lot of interactivity in their courses to assist in getting core concepts across, and this works well, as the best way to learn anything is by doing it yourself. Getting started is free, and they have courses for all ability and knowledge levels. The neural network topic is one they cover in a lot of detail. I've recently been going back through some of the more advanced topics, reskilling on some of the topics I've worked on before, and learning new skills in the areas of network optimization and how best to apply matrices to improve performance. The interactive components really do help to reinforce key points. I got my start with training backpropagation networks to recognize images and handwriting samples, and Brilliant provides you with the knowledge you need. You can learn how to do it for yourself. So all of this positional data for the objects allowed me to visualize the games in 3D. There were a few teething issues to resolve initially, but once they were ironed out, I had a script which could import any game and display it in Blender. In the end, it took over 500 generations and a population of 100 for a Pacman champion to emerge which could beat level 1. Probably one of the most satisfying coding challenges I've done in a while. As always, thanks for watching.